Namaste bachcho, in this video we are going to look at viscosity concept, okay? What is viscosity? Resistance, it is a resistance. What is terminal velocity? What is coefficient of viscosity? We are going to cover in this video. If you have any doubts regarding previous concepts, you can leave it in the pinned comments. So what is viscosity? You are sitting, okay? This is you. And this is your friend. And far away your crush, your crush walks. Crush comes closer to you, it enters the glass, okay? Now, your friend would pull on you, okay? Your friend would pull on you, just go talk to her. And you will resist, right? Like, no. So this resistance of a fluid, imagine this was a fluid. The resistance of this fluid is called viscosity. The internal resistance. You're internally resisting, no, I don't want to. And your friend, obviously. So, what is viscosity generally? Viscosity means that the internal resistance, okay? The internal resistance of the fluid. Now, when I put honey, okay? Imagine I have two slopes. Now I put honey on this, okay? There is this layer of honey. And here I have layer of water. Which would flow smoothly? Water or honey? Obviously water, okay? Because it has low viscosity and honey has higher one. So we have seen in previous definitions non-viscous. So what is non-viscous? Which does not have any internal resistance, like honey which flows very slowly. And what if we put a layer of honey on it? What happens? This moves slower and this moves faster. Because there is no much surface to stop or to resist. So it moves faster than this does. So when you pour it in a pot, some drops would reach it quickly, but some would stay. So the staying part is the below one, and the one which is flowing faster is the surface, top surface of honey. Now, let us look at the general formula of viscosity. So, what is the general formula for viscosity or viscous force? Now, if a fluid is resisting, it must have a force, right? Let's take this scenario. You pour a fluid on this container and this is the wall of the container, this green layer, the pink layer is the first layer of the fluid and the white is second one. Now which would flow faster? Obviously 2, but let us look at formula. F directly proportional to A. What is A here? A is the area of this wall, and now when there is less area, it will say like move faster. Imagine this scenario. There is only this small bit of wall and the surface, and you put a fluid in it. It would obviously easily fall down without having any resistance. But more the area, more the resistance. Okay. Now F is directly proportional to A. F is also directly proportional to delta V. What is V? This is a velocity. This layer's velocity is V2. This layer's velocity is V1. The pink layers. So delta V is equal to V2 minus V1. Let's keep this aside. And delta Y. What is Y? Y is the distance between the layers from the wall, from this container's wall. Okay? More the layer, less the force. Am I right? As it goes higher, there is less internal resistance, so there is fast flow of fluid. And when there is less layers, okay? First layer if you take, there would be more internal resistance. Now, taking both cases, F is directly proportional to A delta V by delta Y, and To remove this proportionality constant, what do? You add a constant F is equal to eta A delta V by delta Y. This is the formula for viscous force. F is equal to eta. This symbol is called coefficient of viscosity. And A is the area of the container wall, and delta V the difference in velocities of layers, and delta Y the height of the layers from the container. Okay. Now, so terminal velocity, W's weight of the sphere, W sphere, let's say Ws, is equal to m into g. Now, g remains constant, so m s. Mass of the sphere is, mass is equal to rho v. Okay. Density into volume, and volume of a sphere is, the sphere we dropped in is 4 pi r cube, 4 by 3 pi r cube. Now, rho of substance into 4 by 3 pi r cube into g. Okay. And then buoyancy force. What is buoyancy force formula? The weight of the fluid displaced will be buoyancy. Okay. When you add some external volume, okay, the fluid displaced will be the buoyant force, the force acting on the particle. So what will be the weight of the fluid? Rho of fluid, density of fluid into 4 by 3 pi r cube into g. Same mass but density of fluid. And force of viscosity, we know 6 eta pi r v. Now, we know that at some point weight will be equal to buoyant force plus force of viscosity. So, rho s 4 by 3 pi r cube g is equal to rho f. It will be equal to rho f into 4 by 3 pi r cube into g plus 6 eta pi r v. Okay. Pi r v velocity of the fluid. Now, rho s, in this case we divide totally by pi, so we'll get cancelled out by pi. r square. Now, so we are at this one, and in this to the left hand side, 4 by 3 r square g remains common. And you get rho of substance minus rho of fluid is equal to 6 nu velocity of terminal velocity. Okay? 6 eta. So 4 by 3 r square g rho s minus rho f divided by 6 eta is equal to terminal velocity. Simplifying it more, you just get 2 and 3, and here it will become 9. So 2 r square g rho s minus rho f whole divided by 3 eta. Okay, 3 eta. This is the terminal velocities formula. What was terminal velocity again? The velocity of particle when passing through a viscous fluid. When passing through a viscous fluid, the velocity which remains constant is called terminal